In this lesson, we will talk about domain and range of relations that are discrete. I think most, if not all of these, we'll be asked actually to determine if they're functions or not. But whether it's a function or just a relation, we're going to be learning how to identify the domain and range. So recall that the domain is the set of all input values or x values. And the range is the set of all output values or y values. So in example 1, there's three parts, A, B, and C. We have a mapping, we have a table, and we have a set of ordered pairs. The directions say determine if it represents a function, so we'll just write yes or no, and then write down the domain and range for each. And it says to use set notation. So I'll show you what that looks like. All right, so in part A, we have a 1 going to a 3, a 2 going to a -2, an input of 3 going to a 6, and an input of 7 going to the output of 5. Does every input have exactly one output? Yes, so this is a function. Now the domain means I just want to list these x values or input values. So when it says set notation, we're going to make this little fancy brace. And inside the brace, we're going to list all those x values in increasing order, so lowest to highest. There are no negatives, but if there are, you've got to be careful to put them in the right order. And we don't want to repeat any values that may show up more than once, which in this case, we don't have to worry about that. We have a 1, a 2, a 3, and a 7. This is nice and easy because they're already in order for us. We separate each number with a comma, and that's what our domain would look like. For the range, I begin with the lowest number, -2. And then 3, 5, and 6. So once again, those are already in order for us as well. And those are the output values or the y values. So that's all we're doing for these problems with discrete relations. And discrete just means that we have specific points. In the next lesson on continuous, we'll see just pictures of graphs where all points are connected. So we have infinitely many. If we have infinitely many, we can't list them all with commas, so we'll have a different way of writing that. In part B, we have a -2, 0, 1, 2, 1. So right away I notice with my x values that the 1 repeats. Does it go to 2 different y values? Well, actually, it goes to the same y value. So this is kind of tricky. A lot of students might mistakenly say it's not a function, when in fact it is a function because every x has exactly one y, every input has exactly one output. When we have a 1 for the input, the output is 3. Okay. Now for the domain, remember we're not going to repeat any values, so we have a -2. We're listing all these x values in order. Then we have a 0, and then a 1, and then a 2. Now I look at the y values. I want to once again list them in order without repeats. So we have 1, 2, 3, 4, 3. I'll just write 1, 2, 3, 4, and that's it. You don't have to write the 3 twice. All right, the last one is pretty similar to this, so why don't you hit pause, go ahead and try part C, and then hit play to check and see how you did. All right, so for functions, since we have a 2, 3, 4, 2, 8, I notice the 2 repeats, and the input of 2 here has an output of 4. Input of 2 here has an output of 6. Those are different, so this is not a function. For the domain, I'm looking back at those x values again, 2, 3, 4, 2, 8, and I'm going to list them in order. So we have a 2, 3, 4, 8. I don't need to repeat the 2, so I just write it once. Now for the range, I'm going to look at the y values, 4, 6, 8, 6, 16. In order, I'd start with 4, and then a 6. I don't have to repeat it, and then 8, and then 16. And then I put the fancy little brace around those numbers. So that's it for example 1. Example 2, we're not asked if it's a function. Actually, they both look like functions because they pass the vertical line test. But we're just asked to list domain and range, doing the same thing as above with this set notation. So let's start with part A. If you'd like, you can list the 5 ordered pairs. So this first point here on the left is a -3, -2. If it helps you to write those out in advance, go ahead and do that. Here I have a -1 for that next point. Then I have a 1, 0, a 3, 1, and a 5, 2. And since I kind of went in order from lowest to highest, left to right, and bottom to top, it should be pretty easy from here to identify the domain. I just look at all those x coordinates, none of them repeat, and they're already in order. So I first list the -3, and then -1, 1, 3, and 5. And for the range, I look at the y coordinates, starting with -2, and then -1, 0, 1, and 2. So part B looks like we're doing pretty much the same thing. This time I'm going to try to do it without writing the points out first. That's kind of an optional step to help you if you'd like. Now for domain, I have to remember I'm looking at all the x coordinates. So I'm really just going to focus on this horizontal axis and go from left to right. So this first point has an x of -5. The next point has an x value of -3. And then this third point has an x value of 0. And then this last point has an x value of 3. Now when I switch to range, I have to completely change now to up and down, the y's. So I'm looking at this y-axis, the vertical axis. And I'm going to start with that lowest point, which is 0, 1. The 0 is the x-coordinate. We already took care of that. Now we just care about the y-coordinate. I'm sorry, I said 0, 1, but it's a -1. So this would be a -1, which I list first. The next point then, working up, is at a +1 for the y value. This next point is at a +2. And that highest point on the graph is at a +6. So if it helps to write the points out first like we did in part A, then go for it. If you're able to just look at the points like we did in B and go from left to right to list the domain, and then lowest to highest to list the range, that's fine. Just make sure domain you're looking at the x's and range you're looking at the y's. So this concludes our lesson on domain and range with discrete relations.